Welcome, my name is Spyros Zigouris. I am a computer science professor and you are on videolearner.com. Through this channel you'll find complete lessons and explanations for the International Baccalaureate Diploma Program in Computer Science. In this lesson, we'll be focusing on CPU processing power. Processing power describes how well a device can handle computational tasks. It reflects the amount of work a CPU or a GPU can complete within a certain time, which has a clear effect on how well software runs on systems' processors. Various elements affect processing capability, such as the number of cores, the clock speed, how effectively heat is managed, at least we need heatsink and fan, and how consistently the processor receives power. Although many times you will see processing power as the ability of the CPU to execute instructions, often quantified in terms of clock speed. Clock speed is the frequency at which a CPU executes instructions, that is, how often CPU executes instructions. It is typically measured in gigahertz, that is, execution billion of times per second. CPUs typically use a smaller number of strong cores compared to GPUs. CPUs run at higher clock speeds and include features like branch prediction and out-of-order execution, which help them handle sequential operations more efficiently. With support for multithreading and a high instruction per cycle rate, CPUs can juggle several tasks at once and deal with complex computational workloads effectively. Now, GPUs rely on a wide parallel structure built with hundreds to thousands of cores, which lets them tackle large parallel workloads efficiently. You have already seen from previous videos that we have multithreading in GPUs as well. Multithreading in GPUs involves massive parallel execution of thousands of lightweight threads, grouped into blocks executing the same instruction on different data across many cores. Now, just remember that executing the same instruction on different data is SIMD. Their high memory bandwidth and specialized units, including tensor cores, boost their ability to move through big data sets quickly. With SIMD support, a GPU can apply the same operation to many data elements at once, raising throughput for tasks suited to this model. Although each GPU core usually runs at lower clock speed and uses simpler instructions than a CPU core, the vast number of these units delivers exceptional parallel performance. These simpler instructions are crafted for parallel use, which makes them specialized rather than weaker. And that's it, we just finished the processing power lesson. In the next lesson we're gonna deal with memory access. From Spyros Zigouris and videolearner.com, bye bye.